Hi, my name is Andy Mallet, and this is Glimmer DSL for SWT, tutorial number 32. So last time we went through how to build the game Battleship. Today we're going to go through another game, Klondike Solitaire. So Battleship was a good demonstration of how to use the various different features of Glimmer DSL for SWT, specifically custom widgets. Today we're going to go through something similar. Klondike Solitaire is a very good example of how to use custom shapes instead. And it's more of a canvas-based app. So this one has a lot of custom graphics. And basically everything that's happening over here is within a canvas. The custom shapes also, like we have different playing cards, we have different piles of cards, etc. So custom shapes are a good example of how to build custom graphics, meaning usually when you build Glimmer DSL for SWT apps, you're using native widgets, using like a text field, radio buttons, checkboxes, etc. This is more of a good example of how to build non-native graphics. So Glimmer DSL for SWT, contrary to popular myth, or maybe not very popular myth, it not only supports native widgets, but it also supports non-native widgets and non-native graphics. And you can do that using the canvas widget. Glimmer DSL for SWT gives you additional abilities to basically compose your own custom shapes on top of a canvas. So basically any visual concept that you could dream of, you could actually build it as a custom shape in Glimmer DSL for SWT. But this sample is not only a very good demonstration of canvas and custom shapes, but also canvas drag and drop, which is different from standard widget drag and drop. Like when you're dragging from a label, you're simply dragging the text value of that label. But when you're dragging a card, like here, like a playing card, you're dragging a fully custom concept that might not necessarily have text on it, or it could have text. Either way, you have a very specific custom intent with what you're doing with dragging the card. So in any case, let's start by introducing Klondike Solitaire. So I mean, this game was very popular on Windows back in the day because it came with Windows for free. The way it works is you have 4 foundation piles over here that you need to fill with cards in order to win the game. You have a dealing pile here that has 24 cards, and you can deal them into this Delt Pile over here. So by clicking on it, I can deal a card. And then we have here 7 column piles, and every column pile has more cards than the one before it. So this one has 1 card, this one has 2, 3, 4, 5, 6, 7. And the very last card of each pile is revealed. So you can see the cards at the bottom, but I cannot see the card that is right before the last one or any of the other cards. So they're all red, meaning they're flipped or hidden. And then here, the dealing pile is usually hidden, but every time I deal a card, it becomes dealt, so I can see it. And the game has different versions. It has a version where you can deal 3 cards at a time. But for the purposes of building a Glimmer DSL for SWT sample, I thought of keeping this game simple, so we only deal 1 card at a time, which is the simpler version of the game. The goal is basically to move cards from the Delt Pile into the column piles, and also move cards from the column piles into the foundation piles. You can also move cards from the Delt Pile directly to the foundation pile, depending on the various conditions that you might encounter. So let's start explaining the rules of the game. Basically, in order to move a card from the Delt Pile into a column pile, it has to be 1 number below the rank of the card at the bottom of the the column pile, and a different color. So, for example, I have a 2 red here. This is an ace. An ace is considered 1 in this game. So it's 1 and it's the opposite color. So that's legal. So that means I can move it and put it here. However, that's not the end goal of the game. The end goal is to actually move cards into the foundation pile. So I could have moved it directly into its own foundation pile. In this case, it says spades. So I'd have to move it here. So that's the end goal of the game, is to put it here in the end. And once I fill all of those foundation piles, basically incrementally in ascending order from 1 to 13. So 13 is king and 1 is ace. you win the game basically. And that would involve moving every single card from the dealing pile into the foundation pile, as well as every single card in the column piles too. So let's start playing the game just to show an example, because there are a few other extra rules involved. So for example, I can move cards between columns as well. So this 6 is one number below the 7 and it's the opposite color, so it's legal for me to move it here. And then I can move the 5 over here. And every time you move a card, it's beneficial because it reveals the card below it. So now I can move this over here. Now I can move this over here. And this now reveals a special rule. If you ever empty a column pile, you can actually fill it with a king in the future. Like, so I just emptied this column pile, but if I want, I can legally move a king. And when you move a card that has other nested cards below it that are all revealed, all of them will move together. That's another feature of the game. So I can move this king and it'll move all the other cards. And the benefit of this is that I got a chance to reveal yet another card. And the more cards you reveal, the more you can move cards around. So this 10 is black, so I can move it below the red jack. This 9 is black, I can move it below the red 10. And now I ran out of moves. So once you run out of moves, you can reveal more cards from the dealing pile. So you can deal cards. So I'm going to deal a card. So we got a 5. There's nothing to do with the 5, with a red 5. There's a red king. There is something we could do. We can put it here in the empty column pile. So only a king could be moved there. Other cards cannot be moved there. So, and as you can see, when you drag it, it reveals the card behind it. So, and the game has, rules that are checking if your moves are legal or not. So if I try to drop this into here, it is not one number smaller with an opposite color, so it's an illegal move, so it'll deny it. Or if I try to drop it somewhere like outside the game bounds, it'll also just deny that move and restore it. Otherwise, you can move something into the foundation piles directly. So this is a legal move. And every time you move a card, you see the card behind it, but we couldn't do anything with the 5. So let's reveal the next card. It's a red 6, red 3, red 6, black 2. Okay, so there isn't a red 3 anywhere here for us to move this 2 on top of, but however, I just noticed that this 2 now could be moved into the foundation pile because we moved the ace first. So you can only move cards incrementally here, so 2 comes next, so I can move it and put it here. So a 4, cannot be, we cannot do anything with the 4, but then again, I can deal the next card and keep dealing the next and next and next card in order to do something with them. By the way, if I keep running through this list till the end, all the way to the end, I just want to show you special behavior that happens. So there are 24 cards originally in the dealing pile. Once I've emptied all of them into the Delt Pile, and this is empty, I can click on it one more time and it'll actually reshift those back here, and then I can redeal them again. So you can actually cycle through the cards multiple times until you've moved all of them into the column piles and then eventually into the foundation piles. But I mean, that's pretty much what the game is about. And once I moved all the cards to the foundation piles, I win. But then once I win, I can restart the game, start with a new one. And then here we have menu items at the top, like I can restart the game from here or hit exit, or I can use a shortcut, Command R, or I can click help about and just learn more about what the game is about, or just learn what the name of the game is, or who made it, etc. That's what you could put in that dialogue. But otherwise, let's start looking at the code. So I'm going to move this to the left side. And you can see here we have a Klondike Solitaire class. It's a custom shell, meaning it's a custom window filled with custom things. It's a custom app. It's not just an empty window. A shell, so if you look at the body, the shell is the topmost widget, and it's basically, in SWT, that's the name of the widget that represents a window. So that's why we call it a shell. But before constructing the body here, we're saying build the game model. So we build the game model, we initialize a whole bunch of constants, but then we get into the body. So we construct a shell, which is the window. It has a special layout. It's got a minimum size, a text, and a background of dark green, as you can see over here. But then the key thing is that there are 3 topmost widgets on it. So as I've recommended in previous tutorials, you always want to keep the topmost body as simple as possible and as focused as possible on the high level concepts of the app. So the high level concepts is we have a Klondike Solitaire menu bar, which is this thing over here. So this is a custom widget used here in order to declare the menu bar. This is building the action panel, which is over here, which has a single action, restart game. And then finally, this is the tableau custom widget, which is representing the entire playing area. So as you would imagine, in order to learn more about the GUI, we need to dig more into the various custom widgets that we're using over here. However, before we do that, let's take a look at the models in order to understand the mechanics and logic of the game first. And I'm going to give you an overview of what the models are in the game. So we have a card model that knows its rank and suit. We have various pile models. So we have a dealing pile, a delt pile, and then 7 column piles, and then 4 foundation piles. We have a game model that's representing the full game, and that's pretty much it. So let's start jumping into the model code. I mean, I can keep this here, that's fine. So I'm going to open Gladiator, which is the Glimmer DSL for SWT editor that I built for my own uses for Ruby programming. So I open all the models on the top, in the top split pane, and I open the views in the bottom. So before I go there, this is the Klondike Solitaire class we were just looking at, and it's over here. It's under samples elaborate. However, if I scroll up a little bit, you can see there's a Klondike Solitaire directory matching the name of the Ruby file, and it's got a model namespace and a view namespace, and that's a very good way of organizing Glimmer apps, Glimmer DSL for SWT apps. So the model will contain all the models, and the view will contain all the views. So let's jump into the game model, and then nice thing is I can actually zoom in and maximize this code area. So a game model knows its deck. It has a deck of cards. So we have one unique deck of cards. That way we make sure we don't get any extra cards that aren't supposed to be in the game, or etc. So we have a deck of cards that guarantees the correctness of the playing cards. We have a dealing pile, a delt pile, column piles, and foundation piles. That's pretty much it. It's a very simple model. It'll construct them on initialize, and then if you restart the game, it'll reset them. And then here it'll just take a deck of the playing cards and shuffle it on every restart of the game. So that's pretty much it. So if we were to jump into playing card, this is everything relating to playing cards. So it knows the suits, which ones are black, which ones are red. The rank count is 13, meaning one as an ace, 2, 3, 4, up to the jack, the queen, and the king, which are 11, 12, and 13. So it can generate a deck. The deck is formed of suit decks, and every suit decks, the suit decks are formed from a single suit deck per suit, and they then go up from rank 1 to the rank count, which is 13, the maximum. You can display the rank text, and it knows to display ace or jack or queen or king for special cases, for special numbers. And then the suits are spades, hearts, clubs, and diamonds, and it uses emojis to display them. Finally, here are the attributes of the model when initialized or constructed. It's got a rank, a suit, and it knows whether it's hidden. It has its own color, and it displays the suit text and rank text. That's pretty much it. It's very simple and focused. Next, we have the dealing pile. The dealing pile has 24 cards initially. It basically will initialize all its playing cards based on that number. It'll basically take a deck that was built and shuffled, and it'll pop the cards from it one by one to ensure correctness of the cards. And then here it gives you a method. So it knows its own playing cards in this method, which is playing cards, but also it gives you this method deal, which enables you to deal a new card into the delt pile. And you already saw how that was working. So I mean, to review that, this is what happens when I click this button. That is what deal is. It deals a new card into the left side. And as you can see, if I grab one of them, it reveals the one behind it that was dealt behind it. So I just delta 5, behind it was a 2. So this is what deal is, and it'll basically shift a card from the beginning of its list of cards. A shift is kind of like a pop, but from the beginning of the array. If there is a card, it'll push it into the Delt pile. If there isn't a card, it'll basically assume that you reached the end. So that happens when I reach the end of dealing all the cards. So let's keep dealing till we've reached the end. Okay, so we just reached the end. So now if I deal one more time, it'll actually grab all the cards from the Delt pile and put them again back into the dealing pile. So that's what that does. So if we go next into Delt Pile, this one is very simple. You can push cards into it or you can remove cards from it. The column pile basically will initialize a column pile, and it knows its count. So as I've explained, they begin from 1 to 7 cards initially. When it initializes itself, it resets itself right away, and as part of that, it'll repopulate itself with cards based on its count. And when it populates itself, it'll hide all the cards except the last one. The last one will not be hidden. So this is what you see here, where all of those are hidden except the last one. And then you can add the card onto it, and it has the rules for checking whether the move is legal or not. If it's not legal, it'll raise an error, an exception. If it's a legal move, it'll push the card in. So this ensures that, if I move here between cards, and let's just say I pick, let's try to find a legal move. So this is not a legal move. This is not one. Okay, this is a legal one. So if I grab this 9, let's do an illegal move first. If I try to put it under the 7, it's incorrect because you can only put it under something that's 1 rank higher with an opposite color. 7 is actually smaller and it's the same color, so it's impossible. Even if it was a black 7, it's impossible. But so if I try to put it here, it'll go back. That's because the error got returned, the exception got raised, and then the view layer handled it correctly. I could take this and put it here though, and there you go, it got dropped successfully. So, I mean, this is a good example of canvas drag and drop, but we'll visit that later once we get to the view code. But as far as the model logic, this is how it works. So this checks all the rules, and then remove will enable me to remove a card from the column pile. That happens when I'm removing, say, let's just say I'm removing this queen, and I want to put it nested under a different model. I can do that. So this is, let's see, so if I were to put this here, I'm going to try to find a case of that. So I can move this here. C3, Jack, 7. Okay, this works. Okay, here's a case. So I can move all of those 4 cards together by dragging them from this column and putting them in this column. So what happens in that case is it'll remove that card, and it'll figure out all the cards that are beneath it, and it'll remove them too. It'll basically, using this method, build a list of cards, removed cards, and it'll unhide them. It'll unhide the last card. So when I remove those, the last card after that is this one. This one is hidden. So when I remove those and put them here, this one will get revealed automatically. So that happens here. And then the cards are removed at an index. So the nice thing about column piles is you can move multiple cards at a time. And the beauty of the view code, once we revisit it, is that you don't have to do anything to move 4 cards. All you have to do is move the top, and the other cards are nested within it, and they have relative positioning to it. And when you move the top card, it's considered the parent of the other cards, so they will all move automatically. So I don't have any code anywhere that says move also all of those cards with the top one. The simple support of Canvas drag and drop in Glimmer DSL for SWT will enable you to do nested drag and drops as well automatically, without having to deal with all the details of all the nested shapes within the parent shape. So obviously that made programming the game very quick, like very, very productive. I mean, seriously, it's like as productive as it gets. It's basically the way I think about it is the way how it's programmed. Like when I moved those 4 cards, I'm thinking I'm moving 4 cards together. You don't have to manually program that. By defining that in the view, they will all move together. And we'll visit that once we get to the view. But this is how it works in the model layer. Obviously, a column pile knows its own playing cards, so that's why we have this method. And this is just a printout of it if we're debugging. Finally, we have a foundation pile. The foundation pile enables us to, it starts out as a clear pile, as you saw over here, like this one. But then you can add cards, and then it checks the rules, and if it's a legal move, if it's a legal move like this one, 2 of spades can be moved on top of the ace of spades. That's a legal move, it'll get accepted. This one will also be legal, so that will get accepted. We're being very fortunate here. All of them are legal. Okay. Now, this one is not legal. If I try to move this one here, it doesn't belong to the same suit, so it's incorrect. If I try to move it here, it's incorrect as well. You can only move cards incrementally. It has to be a 3 to go here, like in a sequence. So only contiguous cards. I cannot move the 8 here, so that wouldn't work. So all of this is managed over here. So that's pretty much it as far as the models. Now let's start looking at the views. So we have the Solitaire Menu Bar, and the body of it will basically construct a game menu with a restart action and an exit action, and a help menu with an about action. And we saw this over here. And you can declare an accelerator, meaning a shortcut for the various things like option F4, command R, etc. These are just accelerators. In the about dialog, it'll call display about dialog, and it'll build a message box, which is how to build quick text-based dialogues. That's pretty much it. Display is a singleton in Glimmer DSL for SWT that lets you access global things related to the operating system. So for any app on the Mac only, you have an about menu and a preferences menu that you don't have to define explicitly. It's actually predefined, but you can just hook a listener to it. So if I go here, this about here will automatically trigger something when I hook into it. So if we were in the game and I do this, it'll trigger the about. So this is how to hook those up. Next is the action panel. This just has a restart game button. So it has a button of restart game, and it'll just restart the game. That's pretty much it. That's what happens when I click this button. It'll basically reset everything and reshuffle the cards and generate a new dealing pile, as well as column piles. So if we go to Tableau, that's the interesting part. So as you can see, this is the canvas topmost widget that hosts everything that happens in the game. So this is the Tableau. So this one is a custom widget, but everything declared within it is custom shapes. So foundation pile is a custom shape keyword that gets added to the DSL automatically as a first-class citizen, just because we declared here a foundation pile class that includes Glimmer UI custom shape. So that automatically makes this keyword available for us. And then I can use it and declaratively build a foundation pile. I can build a Delt Pile, a dealing pile, and column piles. Row 1, row 2 is just me aiding myself in remembering what it's doing. But basically, this is row 1, this is row 2. So we have the 4 foundation piles, the Delt Pile, the dealing pile, and the column piles. That's pretty much it. It's very declarative. It's very simple, very close to how we see shapes on the view. The key difference between custom shapes in general and custom widgets is that custom shapes will usually take an X and a Y coordinate that are usually relative to their parent, and that's how you position them on the screen. So they're all pre-calculated here in order to display those 4 cards here. This is this Delt Pile here, the dealing pile here, and then the column piles here in order. So now we can start digging into the various concepts as custom shapes. So we have the different piles, but beneath that we have the cards. So let's look at what a playing card is. So a playing card is, as you can see here, is like a rectangle that has curved corners and rounded corners basically, and it's got text within it that's representing the rank, and then also an emoji that's representing the suit. And then it has a white background and it has a black border. So you can see this over here. This is the rectangle. It has x, y coordinates, width and height, but additionally it has rounded corners, so it specifies additionally the degrees of rounding the corners horizontally and vertically. It's got a background that changes depending on whether it's hidden or not. It has a border, so it has an inner rectangle that's basically filling the width and height the same way, so it ends up being a border. It's also rounded and it's black. And finally there's text, and the text is rendering the playing card model, rank, and suit text. And it's got a foreground color, and it's positioned at the x5 and y5 relatively to the parent rectangle. So that's why you see this, 5 pixels away from here and 5 pixels away from here. So that's pretty much it. And every playing card knows its own model. So that's the way to do MVCs. Every view knows its own model and observes its own model and then reflects changes in its own model. And you can also sometimes use presenter instead of model if you want to have extra presentation details not coded in the model. So next we have a hidden playing card. Hidden playing card is always hidden, always has a a red background. So it's very simple. It's used here in the dealing pile because it's always a hidden card there. And then an empty playing card is when it's empty. So this is an empty playing card, but this one is used in a foundation pile, and it knows its own suit, so it displays it here. And it's got a painted border that is gray, but this is a different kind of empty card that doesn't have a suit, and it's used in the Delt pile or the dealing pile. So that's what this empty card concept is. And then finally we have the different piles. So we have a dealing pile, and the dealing pile will simply observe the model playing cards, and it's doing here something called nested observation, which you could do nested data binding with Glimmer DSL for SWT, or you could do nested observation. So in this case we're taking it, so you don't have to always follow the MVP pattern where you have a view that's data bound to a presenter or a model. You can also do MVC, so you can use a hybrid of the two different patterns. In MVC, usually the view will observe the model and then it'll refresh itself when model changes happen, and that's what we're doing here. So the after body is usually where you want to declare observers because it happens after we've built the view. So we build the view and then we can make observations of the model and then update the view further. So what we're doing here is saying we're gonna observe all the playing cards of my model, meaning all the cards that are in the dealing pile, and then I'm going to observe whether they're empty or not. So this is doing nested data binding because it has a dot operator. So this will actually basically observe, it'll basically fire this block action whether the playing cards changed or not on every change to them, and whether the empty status changes or not. And then here it'll give us an empty value, and generally it's not empty. So when it's not empty, it'll just show a hidden playing card. That's why you always see a red over here. But once it becomes empty, it shows us an empty playing card. So it's very simple. It's just a binary of these two cases, empty playing card or hidden playing card. That's it. And here what it's doing is reopening its body root content. So body root is the widget that is at the topmost. So this is a custom shape, so it's not a widget, it's actually a shape. The shape object that is at the topmost of this dealing pile, so a body. So here the body root is the very first shape that appears here under the body and is returned as part of returning the body value. So this is the body root. And shape, when you say shape, this is just a generic shape that is basically representing a general shape, and then within it you can declare specific shapes. So by default I start with a hidden playing card within it, and also I have a listener here that's saying if I click it with the mouse and then mouse up, meaning I remove my finger from the mouse button, it'll basically deal a card. It'll call its model, which is the dealing pile model that we saw earlier, and it'll deal a card. And that's all it does here. So this listener is an implicit controller. It enables the user to control the user interface. So when they click it with the mouse, I'm controlling it. And the controller will just basically call the model deal, this implicit controller. like this block, and it'll deal a new card into the Delt Pile. So now if we jump into the Delt Pile, this one again is following MVC, the pure MVC pattern, and it's basically observing its own model and its own playing cards and whether they're empty or not. And if they're not empty, it'll basically take the card and will generate a new playing card view, a custom shape for it, and it'll give it all the different options, and then it'll declare that the playing card is also a drag source. A drag source means the playing card is draggable. So when you declare drag source true, I'm saying this one is draggable. Unlike this one is not draggable, but this one is, I just dealt a card though. But I cannot drag it, but if I remove my finger from the mouse, it'll deal a card, but it's not draggable. But here, this one is draggable. I can drag it and it'll reveal the card behind it when you drag it. So that's what this is doing. This is just handling an edge case, which we don't need to get into right now, but this is the key part of the logic when the list is not empty, when the playing cards are not empty. But if they are empty, then it just shows an empty card. Basically, it'll kill all the other cards, it'll dispose them, and then it'll show an empty card. So that's pretty much it. It starts with an empty card in the beginning. So this is the initial body. Finally, we have a column pile. The column pile will start with an empty shape that just has an on-drop listener. Well, whenever you have an on-drop listener, this shape automatically becomes a droppable, a drop target, meaning you can drop things into this shape. And this on-drop listener is, again, an implicit controller that will handle the details of what happens. And controllers usually, when you're following MVC, will always generally work with the models, not with the view. It'll grab data from the view, but then it'll talk to the models and have the models make the changes. And then the views will all be observing the models, and they'll update themselves automatically because of those observation calls that we declare here. And by the way, this observe keyword I didn't mention before. It comes from Glimmer DSL, from the Glimmer DSL for SWT. And it's useful whenever you want to follow MVC as opposed to MVP. And this is a good case of doing that, is when you're changing various shapes and you want to dispose of shapes, old shapes, and regenerate your pile from new shapes based on the model playing cards. So this is a good case of following the pure MVC. So the key thing here is that we're building a body with this on-drop listener, so the column pile is always ready for dropping something onto it. But also, after building the body, it'll build the column pile once. So here, it'll basically take... If it was run after it's been initialized, it'll actually clear the previous shapes. But otherwise, it'll grab the body root, which is this shape, and it'll loop through the cards, iterate through them, and then it'll take that current parent and reopen its content, and it'll dump in a new playing card, and it'll fill it gradually. But every time it dumps a playing card, that new playing card becomes the new parent, and then it dumps a new playing card underneath it. And every playing card that's declared is a drag source, meaning it's draggable. So what that is doing is basically it took this card and it put it under the column pile, top left corner, and then it made it the parent, and then it declared another card and put it underneath that card with relative positioning, and it automatically positioned it in relative to it with that much spacing, and then it built this list basically one by one. The benefit of that is that now every card is a parent for the next card. So that means if you drag this card, it drags all its children together automatically. I don't have to code any of that. Glimmer DSL for SWT will automatically recognize parent-child relationships between shapes. And if you drag the parent, it'll drag all the children automatically all together. So that facilitates programming the game significantly because I don't have to deal with any of this logic. I don't have to code moving the children manually. I don't have to deal with drag and drop complicated details for all of that. I can just think of it as an abstract thing, exactly the way I think of it in real life. If I'm laying these playing cards on a table and I'm moving all of those, I would think of them as a unit, and I'm moving the entire unit somewhere else. So that's what this enables us to do. let's get back into the code. So this is what the column pile is about. Also, it's observing its own playing cards and making and checking if the hidden status of the last card got revealed. But this is a nested data binding, so it'll fire on any change to playing cards, it'll fire on any change to the last card, and it'll fire on any change to the hidden status of the last card. So if any of these things happen, it'll rebuild its own column pile. And so it'll dispose of all the shapes and rebuild them. And that will rebuild this column pile. Finally, the foundation pile will also begin with a shape, and it begins with an empty playing card, and it's also droppable, so it has an on-drop listener, so you can drop things onto it. But also it'll observe its own model playing cards and the last one, and if there is a card, it'll basically render that card, so it'll fill the content of its body root with that card. So whenever I drop a card here, it'll basically get rendered over here. Like when I dropped the 2, it got rendered. So it got added into the content of its shape. Otherwise, it'll just clear its shapes. So when you reset the game, it'll clear those shapes and start again with an empty playing card. And again, it's following MVC, it's observing its own model, and it's reflecting or re-updating itself automatically on changes to the model. And then when you drop a card, it also, it'll basically take a look at what card you dropped into it. It'll add the card to its model, and it'll remove the card from its source. So if I can drag a card from here and drop it here like this. That just worked. Or I can drag a card from here and drop it here if it's a legal move. So it'll basically delete it from its source. It'll dispose of it. And it'll remove the card from its source as well. And if the move is illegal for whatever reason, it'll throw an error. It'll rescue an error over here, and it'll basically here cancel the drop action. So when you say drop event do it false, it cancels the drop. So that's like me when I drag the 7 here and put it here, it gets canceled, so it goes back to where it was originally. And Glimmer DSL for SWT will automatically handle bringing that shape back originally to where it was before you dragged it, so you don't have to worry about that. The column pile, by the way, we didn't look at its on-drop listener, but it does something very similar. It figures out from the drop event what the dragged shape was, and then it grabs the model of the dragged shape, which is a card, and then it adds it to its own card. And then here it checks if you're also dragged in an array of extra cards. That happens when I'm dragging multiple cards like that. And if it is, it'll move all of them as well. It'll add all of them to its model. And then finally, it'll dispose of the card. So that's pretty much it. And so if you were to summarize this app, basically it's a canvas-based app. It lets us be able to build our own non-native concepts in Glimmer DSL for SWT. So unlike native widgets like button or text field or radio or checkbox, which usually are based on widgets from the from the operating system, you can also build your own non-native concepts if you want. So you're not limited by Glimmer DSL for SWT with native widgets. You can also build your own non-native widgets, and that's what Canvas allows you to do. So then we can build our own concepts visually, like cards, and then do drag and drop effortlessly because of the drag and drop support that's declarative in Glimmer DSL for SWT. This enables you to write an app that has custom graphics and custom drag and drop events very, very efficiently, very, very productively. The nice thing about this also is that the code usually is split between declarative code and imperative code. So generally when you build the GUI, it's declarative. I'm declaring I have a rectangle here, I have a rectangle within it or around it, that's a border, I have text within it, etc. So that's basically a declarative presentation or declarative GUI. However, whenever events get triggered and we have listeners that are listening to those events, like in this, let's look at an example that has an on-drop event, so column pile. So whenever an event like a listener like this fires. This is an implicit controller. And so this block is a sort of a controller, and because it enables the user to control the app. And the controller will then cleanly grab data from the view, like figuring out which card we're on, figuring out the model, but then it'll basically make the models do all the work of figuring out if it's a legal move, adding the card, adding extra cards if needed, and then if the model denies the move, it'll raise an error, and then we'll handle the error here by canceling the drag and drop. So basically, usually with the Glimmer syntax, for example, so let's look at this file. Within the body, you're writing declarative GUI code. So intentionally, we follow the Glimmer style guide. We don't follow the Ruby style guide because here we're in DSL space. We're in a domain-specific language. In this DSL space, we're representing a hierarchy of the widgets that are on the screen. So we have a window, a shell. It has properties within it. So here, you don't say do end like we do in Ruby usually. You just open braces because we're declaring. We're not doing work, we're declaring. I'm declaring a shell. I'm declaring properties on it. I'm declaring widgets within it. And for every widget, I'm declaring extra layout details or properties. So you use this kind of curly brace block. And in fact, you imagine yourself not in a block because here we're in a DSL. We're just visualizing this hierarchy that we have, a window that contains an action panel and a tableau. That's it. And then the tableau contains, the foundation piles, the Delt Pile, dealing pile, and column piles. So that's what we saw over here. So again, it's all declarative. However, when you're doing, the nice thing about being in one language in Ruby is that we can do declarative for the things that could be declared, like the view and the GUI, and then we could do imperative for things that are imperative, like what is the action that will happen when somebody triggers, drops a widget basically on top of this shape. Well, when you drag drop another shape on top of this shape, this is imperative code. So that's why here it says do end. So it's important to follow the right style guide. This follows the basic Ruby style guide because basic Ruby is imperative. And then the other one, like here, this is following the Glimmer DSL style guide. So it's important to keep that in mind. And basically this enables very simple separation between view representation and view logic. So view presentation is declarative, view logic is imperative. Unlike, say, other libraries that you see nowadays on the web that will use the word render, for example. They like some libraries, to be honest, they're lying to you. They tell you they're declarative, but they use the word render, meaning you're imperatively saying render this. If you're saying render, you already failed the whole declarative test. You're not declarative anymore. You're imperative. Whereas here, I'm truly saying I have a body. So I have this component, column pile. I have a body. I'm just declaring it, and then I'm declaring a shape underneath. I'm not doing the render work, or I'm not at any point telling the view when to render. That is handled automatically. We don't have to worry about it. It's just the way you think about things in real life. You just declare things. I'm declaring I have a card, I have a pile, foundation piles. Like I have a tableau, first of all, and then I have foundation piles on the tableau. I have a Delt Pile, dealing pile, all the different column piles, and then within each one I have a playing card or playing cards, etc. However, the nice thing about the one language approach of Ruby is you can mix declarative and imperative code. And you already saw examples of that, like, let's see. So if we were to look at the tableau, that's a good example. So here we are, imperatively looping through a list of playing card suits. And for every suit, we build a different foundation pile. So the nice thing is here, this is imperative. We have to loop through this list. But then when we declare the widgets, they're declarative. So you could do some logic that is imperative, like iterating through collections in order to render them. Though arguably, we could think of this as also declarative code. Like I could, in a way, think of it like do this and think of this as, this is a declaration of the different foundation piles based on the suits. That is one way of thinking about it. But in any case, you can mix declarative and imperative code whenever that is pragmatic and useful, like in this case, or in other cases, like when I add a listener. Once I add a listener, so declaring the listener on drop is declarative, but then when the listener starts doing its work, I have to say, on drop, do this. For example, on widget selected, do that, etc. So that's an example of being able to mix imperative and declarative with no multi-language dissonance, because we're using only one language, Ruby. Unlike, say, in web development, where you have to mix HTML with JS, with CSS, with a whole bunch of things, like different things, and it confuses everything together. Here it's a lot simpler. It's uniform and it's very simple to maintain. So yeah, that should give you a very good example of how to build canvas-based apps, or canvas-based widgets at least, within an app with custom graphics, as well as canvas drag and drop effortlessly, thanks to the built-in canvas drag and drop support in Glimmer DSL for SWT that lets you be able to declaratively declare a shape as draggable, or a parent shape like this. Like I can drag the card and it moves the text and it moves the border, rectangle, and everything within it together, or all of those together. That's because of declarative drag and drop support. So in order to learn more about Glimmer DSL for SWT, check out the GitHub project.